Hello everyone, this is day 2 of 30-day challenge. In the previous day, we just discussed about what is machine learning is and how we can get access and play with the data that we have in our data set. And now today we're going to be discuss about the data visualizations and how we can see and find pattern from the data. I'm extremely sorry for the late video. It's almost 11 p.m. here, and I had to take multiple shots for this video, maybe. So that's why. I had exam today. So after finishing the exam, I came back and did the whole things revise again because, exam had some pressure. If we have basically that's for varsity academic final exam. Anyway, so challenge have to be challenging. That's the part of the game, right? So let's understand why visualization is important for your data. At first, we just go through the numerical data that we had, but that doesn't make any sense to us. It's just showing some numbers and numbers and numbers all in all. So we are not understanding what we're seeing about what these data are. What does it mean actually? Although we know their houses prices and the rooms and etc, quantity etc details, but that doesn't memorize and find pattern for your brain. Although alhamdulillah we have a huge creative brain by our creator, so it's easier for us to understand any pattern from any visual. That's why the visualization is important, although there are some others importance also, so I'm not going to discuss all about them. So visualizing geographical data. So let's say about you are visualizing some longitude and latitude, and you are combining them to make a visualization graph for you. And once you make a visualization graph with longitude and latitude, you will probably get to see some dots on your graph as like this. This is a basic graph. So that doesn't tells a lot of things, but it shows that there is some density or there is some dense area in this part. So on dense area the population might be more, or on the other hand on the less dense area the population might be less, something like that. But this dot is properly black and we don't have any like density area, proper visualizations about how much populations indicator. There are no populations indicator, there are no pricing indicators or nothing like that. So this type of graph is called as bad graph in this book. Bad quality graph. So there are some updated quality graphs. So this shows a better visualizations graph, as you can see there. Okay, so these visualization shows they have some opacity management there, and it shows the dense area clearly with the more dense area, because for each dots or each spots you are getting amount of visualizations there. So for when a lot of dots comes together, it getting more dense and black, rather than just having a single dot, how that looks like. So by the end we're getting a colored visualizations that shows us how dense, how populations are there, and how many how the prices are, and also along with the maps behind them that gives us idea about the areas also. So in this data set we are seeing the data of a Bay Area. So as usual, the Bay Area housing price is going to be higher than the local area, right? Or that's far from the Bay Area. So this is what the these data shows actually. So I'm gonna be attach 3 of these chart on the video probably if I get time, but I don't think so I will get time because it's already like hitting the time of the day and I have to complete this challenge. So yeah, I'll probably add them on the comment. So basically it gives us an idea about and in showing us the real data with the real position and things. I mean, by looking to the colored image, I mean the best or the better image, we can have an idea about which area is more dense, which area have more populations, and it is using a color graph, so it's making more sense to us to have like proper visualizations with a heat map, something like that, that shows from different color range and from the area also. And if you just look into it, and that will make more sense to you. So I'm not going to be talk anymore about them. So it is important to have visualizations of your data to understand how your data is, and then you're going to be program your model in that way. That helps your brain to understand the core pattern of it and program of it. I mean, program the whole model around it. It makes more sense actually, as far as I understood. So then we comes to look for correlations. Okay, so once you have the data, once you have the visualizations ready, your job is to find some correlations between the data. What does the correlations between the data means actually? So in theory, the correlation in machine learning is actually finding the relations between two variables, number one and number two. So you are finding the two you're trying to find the similarities and connections between these two variables. For example, okay, before I give you an example, there is a range of correlations number that is from -1 to +1, and 0 is the middle one that shows no linear link or zero correlation. So the positive correlation is basically +1, that's the perfect positive correlation, and the -1 is the perfect negative correlation, and the number varies from -1 to +1, as I said. So let me give you some example what is positive correlation mean to be. Okay, so if you do study more, you will get more better result, right? And that means, like, if your value goes up, I mean if your impact goes up, then your value is also going up. This is called perfect positive correlation. And on the other hand, the perfect negative correlation is going to be if your impact goes high, your outcome will be goes down. For example, if you upscale your price of your model, then probably less people are gonna buy your product, right? Or your model. So this is called perfectly negative. I mean, this is not called perfectly negative because perfectly negative depends on scenario. So perfectly negative have to be -1, proper -1. So depending on the scenario or use case, we might rate it from 0 to -1, anything behind them. So we have now an example of perfect positive and perfect negative and how these things work. I mean, perfect negative is if impact goes high, your result going to be down. They will be not similar, right? Then it comes to 0. That means no linear link. So for example, your shoe size doesn't relate to your IQ score, okay, of your brain. So it doesn't mean anything to your shoe size, right? This is what called zero linear link. You have no linear link to there, that calls 0. Then the correlation value will be 0. So this is what we have to find in the data that we're having, and that gives us a strong idea about what type of, I mean, depending on the scenario, it obviously depending on the scenario, these things depends. So as it says, the correlations, it measures the strength and direction of linear relation between two variables. Okay, this is the definition of it. So let's go to the next page and see what's there. Okay, there are two ways we can find the correlations between two attributes, and I'm not going to say that. So okay, let's say. So basically, in pandas we can check the correlations between two variables is scatter underscore matrix function by using that. And there is another function that called CORR function. It's for the basic standard correlation coefficient formula actually, to get the correlation number from there. Okay, so now we have an idea about what this correlation is. It's basically finding the similarities between two variables, how similar they are, in which direction, is it positive, negative, or zero. Now let's go back to the next word that says experimenting with attribute combination. Okay, attribute combination plays a huge role. I mean, it's crucial, right? Because, for example, let me go you through my theory first, and then I'm going to show you the example so that you can have proper understanding about what I'm talking. So some attributes have a skewed right distribution. Skewed right distribution means probably from the right side, I mean the left side gonna be high and the right side gonna be down. It's something like that. You probably seen some graph that is like something like this way, goes up directly and then goes directly to the down or something like that. I mean, one side, I mean from the half of the side will be very high and the half of the side will be very down, something like that. So, and the side that will be down, that will be the, I mean, if the right side will be down, then it will be skewed right distribution. So you want to transform them by using logarithm or a square root. Of course, your mileage will vary considerably with each project, by the general ideas are similar. Okay, so basically when I'm reading these books, some topics are going over my head, so I took some help of AI and Google, and to try to understand the best things that I can understand from here. So I take some note from external resources, which is always open for you to also. So basically it is a crucial process of feature selections to find minimal most informative set of features that maximize the model efficiency while avoiding issues like the causes of dimensionality on the data redundancy. So let me explain you with some example that will make more sense to you maybe. So each value sometimes don't make good decision, but having them combined like Young is okay. So the example is, I mean, the attribute combination is something like you are finding combinations of two separated column or two separated attribute. For example, your age and the location. Doesn't make any sense, like if you're going to buy a house and your age and your location make any sense to the model to predict the house price? No. But on the other hand, if you go to the fraud detection model and your young age and a highly risky area location, it's the age and the location, they comes together and make a huge role to detect the fraud activity or predict the fraud activity for the certain user or for the certain behavior from the internet, right? So this is called combining the attributes and finding the patterns from it and predicting a model in like that. So it doesn't necessarily you have to come through at the starting point, but the thing is like at first you need to start. Okay, what does it say? Let me share it with you in book language. So this round of exploration does not have to be absolute true. The point is to start off on the right foot and quickly gain insight that will help you to get a fast, reasonably good prototype. But this is an iterative process. Once you get a prototype up and running, you can analyze its output to gain more insight and come back to this exploration step. So basically it's saying like you're probably not gonna be have these exact process or these exact combinations of attributes at the first when you're training model. This is a optional, but it gives you a step to go ahead and train your model and then come back and find more data from it, and then maybe probably update your training from your data set, something like that. So yeah, next on the next we have the prepare the data for machine learning algorithms. So here basically there are multiple steps here, because to train our data for the machine learning algorithm to learn from, we have to process it in a multi-step way. So I'm going to discuss that one by one. At first it says like clean the data. So most machine learning algorithms cannot work with missing feature, so you will need to take care of this. So that means like in real life data, they are not organized or they are not properly filtered, right? So you have to clean your data. I'm just taking my time. I'm just hitting the deadline, so I have to make things close fastly, I guess. So cleaning the data makes the understanding about how we are going to clean the data. So for example, real life data, sometimes we get zero value, none value, or something like that, or sometimes a certain column or row doesn't make any sense. So on that perspectives, we might need to delete them, or we might need to like handle some step for them, right? So like you have three options to fix your data or clean your data. Firstly, get rid of the corresponding districts. Basically you are going to remove the part of the data or the values that are not right or inaccurate or something like that, or that have missing values. Number two is get rid of the whole attributes. You have to delete the whole attribute or the columns or the features, something like that. And number three is set the missing values to some value. I mean, you are going to assign some new value to those value. That could be zero, or the mean value, or the median value, or the most frequent value, or the constant value. The zero is basically zero, you are putting it zero or none. And then most frequent value could be the most repeated value that you are getting from your data, that will be placed there. And the constant value could be the one constant value that you assigned previously. For example, I will assign the date, obviously 2025, something like that. And if there are a missing value, then that's going to be replaced with that constant value that I have assigned 2025. This is like that. And the mean and median value is obviously going to be numerical value. So you have to keep aware of that. If you're going to use to replace with mean value or median value, you have to always use them as a numerical data set. So in our data set, we have most of the attributes in numerical rather than just one, that is OSIN proximity. So we can't use that to replace with mean. So we have to make a separate data set here in this case. But depending on others model, it might depend. So the process that I'm just sharing, just replacing some value for the missing values, that is called imputation. So there imputation basically means you are replacing the missing value with some sort of data. That's it. So there we can see the simple imputer. Okay, simple imputer is the same thing. Okay, then it comes to the okay. So how do we insert these data on our data set? With the pandas data frame, we can use dropna, drop, and fillna. These are the three functions or methods these are the three methods basically that we can use to insert the data. So fillna is basically to replace any data with any like mean value or median value. Then dropna is basically removing the missing value only with none or NaN that comes from pandas. Then we can use drop to directly delete the whole whole attributes or the whole column or the row or something like that. So this is what I have understood actually. Then it comes to like scikit-learn design. Scikit-learn APIs is remarkably well designed. They have there are main design principles. So there they discussed about some principles about scikit-learn. I'm just going over the main headlines of that. So consistency is all about sharing a consistent and simple interface. Estimator is any object that can estimate any parameter based on a dataset called an estimator. So there is nothing something more. I mean, this is not so complex to explain actually. So let's go to the next thing, that is transformer. Some estimator can also transform a dataset that called transformer. Those estimator that transform a dataset that are being called by transformer. Then predictors. Finally, some estimator given a dataset are capable of making predictions. They are called predictor. So those estimator given in a dataset are capable of making predictions. Those who are capable of making predictions, they are predictors. Easy. So something like that. And in this way we have the sensible default. Scikit-learn provide the reasonable default values for most parameter, making it easy and quickly to create a baseline working system. So handling text and categorical attributes is the next part. Handling text and categorical attributes make a more sense because, for example, if you have some category of your house and there are like luxurious, mid-luxurious, non-luxurious, something like that, 3 categories for example. Okay, so now how would you make your model to understand them? They don't understand the string value the way we understand, right? So we probably need to use some float value, right? That is like 0 to 1 in range, something like that. So then how would we calculate the different terms of different attributes in attributes of category in a way, differentiating way? So this is what comes in here. So our learning algorithm prefers to work with number. That's why we convert these categories from text to number, and this is called ordinal encoder class. Scikit-learn ordinal encoder. So then it comes to sparse matrix. I'm gonna be discuss about how do we convert them later in this video. So a sparse matrix is a very different representation of matrix that contain mostly zeros. So the matrix that mostly contains 0, that is a sparse matrix, and by using a method to array method we can dense the sparse matrix actually. Then it comes to feature scaling and transformation. This is where this is the process where we can actually make. Okay, I'm gonna be explain that, just give me a minute. So basically handling text and categorical attributes is basically you are handling the text by changing it to a float value by assigning some value to there. But the feature scaling, I think the feature scaling and this is related to them, because the feature scaling is something, this is a very crucial part of a machine learning model to work in a proper way. If you don't feature scale and transform your model, that's not going to be give you the best result. So the feature scaling is one of the crucial part, because for example, if your house, for example, your house is 1000 square feet, something like that, and you have 2 bedroom. So now your machine learning model is understanding like, okay, your 2 bedroom with 1000 square feet house prices is X, and now you are having 1 bedroom with 15,000 square feet. So what does it means? You are getting a square feet value that is 15,000x more, and you are comparing with just 1 bedroom value, right? is it make any sense? I mean, just for the machine, understand them, like 2 bedroom and 1000 square feet versus 1 bedroom 15,000 square feet. So just look at the number. 15,000 is far 500 more than the previous one, and the for the first data we have 1000 square feet and the room is only 2. Okay, so now our machine learning model is going to see that, okay, we have 2 room there and we have 1 room here. This categorical attribute is only half by half, but we are getting 15,000 square feet. It's much more than that. I mean, 1 versus 15,000, the number we are comparing with, this makes your model overwhelmed and calculate the 15,000 square feet as a 15,000x amount of bigger than this data. So that makes the whole conflict. This is where the writer says, this is the case for the housing data. The total number of room range from about 6 to 39,320, while the median incomes only range from 0 to 15. So income range is from 0 to 15, but the house room range is from 6 to 39,000, almost about 40,000. So now, without any scaling, most model will be biased toward ignoring the median income and focus more on the number of the rooms. So it getting a huge number of the room there, and then it's getting ignored for the income range. Okay, and then where the conflicts comes in, because they are not that powerful. I mean, the value that it counting 40k, that they are not that powerful to make the pricing predictions this way. So this is where the feature scaling comes in to solve this problem in a easy way, so that they can handle them in a easy way. So there are two common ways: min max scaling and standardizations. So min max scaling is basically the simplest model. So min max scaling is basically have a range from -1 to 1. It just make the scaling process in a way. I mean, it's something like correlations, right? So they're normalizing the value, okay, so that we can get a much comparable value with our data set. So this is where it comes in actually. And then we have standardizations. This is a different one. So for example, Bangladesh have like, for example, in your office there are most of the people with a salary of 50k per month, and there are your boss who is earning or who have something sort of income that is between 10 millions. So when you are averaging or getting a mean value, it makes more nonsense when you are averaging a 50k salary with a 10 million salary, and the mean value that is there, that getting that's not the actual mean value, right? This is where the standardizations comes in, and you have to standardize the whole value. So you are standardizing the whole process of it, and then you are getting the data there. The actual value that comes in there. So it basically fixing your outlier that's been there. For example, the 10 million salary or the income person who are there, it's reducing their mean value to the actual mean value, so that it can get adjusted with the whole process or whole data. So this is what it does actually by using logarithms there. And yeah, this is how we're fixing the feature scaling method there to reduce the extra outlier that's been come there. This is probably not the outlier, because this is the real inside, but the one data, one person's income that's reflecting the whole process, that's not fair, right? So we're not getting the accurate result then. So this is where we need to have feature scaling to scale and to make our data more precise and let understand our model more better way. We are about to hit the limit. It's 11:15 and I have to edit this video to make the frame smaller and upload it, so that's gonna take a lot of time. Okay, so I have to finish this within 5 minutes, and by the end of this day I will finish this video and finish this topic, inshallah. So then it comes to multimodal distribution, and we also get introduced with bucketizing. So bucketizing is basically we are splitting the whole data in a separate part. For example, if you go to the Facebook dashboard inside, you will probably see the age group, right? Like 18, 4 to 18, something like that, 18 to 25, something like that, 25 to 40, and then 40 to 65, 65 plus. There are bucket size, right? Without just getting the number. For example, age 21, age 22, age 23. For example, so if you go to your dashboard, you are seeing by age data for your statistic. That doesn't make, that make a lot of data to comes to your eyes. But without doing that, you are just clusterizing the whole part of it. You are clustering the young age, you are clustering the adult, you are clustering the old person, you are clustering the child or something like that. So this is where you are just clusterizing the whole part of the data without just showing a tons of data there. This is what the bucketizing is. So in theory, it means like chopping its distribution into roughly equal size buckets and replacing each features with value with the index of bucket it belongs to, much like we did on the blah blah blah. There is an example of this code. Sorry. Another approach is through transforming multimodal distribution to add feature for each of the model, at least to maintain representing the similarities between the housing median age and the particular modes. So there are Gaussian RBF feature measuring method. The similarities between a given input data and data point and a specific fixed central point is basically called Gaussian RBF feature measuring model. So yeah, we are hit the limit of the time, so I am at the end of this chapter actually, of this today's lecture. So the challenge got a bit more challenging because I had some exam. I'm sorry for the late to upload this video, but alhamdulillah, I keep my challenge, and it will be continued, inshallah. Keep prayers for me, and thank you everyone, thank you, and do pray for me, alhamdulillah. So yeah, thank you, bye bye, assalamu alaikum.